So the topic for today is quadratic functions. And this is a lot like quadratic equations, except that we have function notation. And we're going to be graphing these functions. And so one of the things that's going to make it easier for us to graph these functions is to change them into a quadratic equation in the vertex form. Because remember, the vertex form is easy for us to graph. So what we want to do, we have two ways that these can be written in function form. First of all, f of x is ax squared plus bx plus c. This is a trinomial. All right, we're going to write that in vertex form. Let me remind you what vertex form is. This is the y minus k equals a, x minus h, quantity squared. So we're going to take functions and write them as equations, and it'll make it easier for us to graph. Here's the other way that it can be written, and this actually comes from the vertex form of the equation. The only difference is we add k to both sides so that we have y by itself over here and then plus k over here. And we change the y to f of x because y does equal f of x. So that's the only difference. So this is really close to vertex form. But this form right here is what we call standard form. All right? So the first one we're going to start with is this form right here. All right? Notice we have a binomial x plus or minus something squared. All right? So it's already very easy for us to follow. So first of all, what we want to do is replace f of x with y. So here was my original function. I'm going to replace f of x with y. And then what I'm going to do, I'm going to subtract 1 from both sides, and then this will be in vertex form. So subtract 1 on both sides. Then I have y minus 1 equals 2 times x minus 3 quantity squared. And this is now set up so that it's easy for me to graph. So first of all, my vertex is hk. So 3, 1 is my vertex. And if you look down here, this is the equation for a parabola with vertex 3, 1. And it has an axis of symmetry of x equals 3. Because remember, the axis of symmetry is x equals h. So I've got 3, 1 right here. And let's draw in the axis of symmetry. All right, and label it x equals 3. All right, now we know that this is going to be concave up. All right, a is greater than 0 because a is 2. So that means this will be concave up. And the next thing I want to do is find my intercepts. So first of all, I'm going to find my y-intercept. And the way that we do that, set x equal to 0. So here's what I'm going to have. I have y minus 1 equals 2 times 0 minus 3 quantity squared. So let me solve this. I've got y minus 1 equals 0 minus 3 is negative 3. When I square that, I'm going to get 9 times 2 is 18. And I'm going to add 1 to both sides, and I get y is 19. So my y-intercept is the point 0, 19. Now notice that's way off my chart here. But if you notice, this is going to be concave up. Is this ever going to cross my x-axis? It's not. So when I know that if I try to calculate my x-intercepts, they're going to be imaginary numbers, because they're not going to cross the the x-axis. So some of the things that I can do, I can estimate how far up 0, 19 is and draw it from that, or I can find any other point. So for example, I might try and find the point where it's gonna, the 2 and then what the y value is it's gonna go with 2. So let's do that. I wanna find the point 2 something. All right, so I'm gonna put 2 in for x. So I've got y minus 1 equals 2, and then 2 minus 3 quantity squared, because I put 2 in for x this time. So I've got y minus 1 equals 2. 2 minus 3 is negative 1. When I square that, I get 1. 2 times 1 is 2. So I've got y minus 1 equals 2. Add 1 to both sides, and I get y equals 3. So I have the point 2, 3 on my graph. 2, 3 is right here. And I know that I'm going to have a mirror image point on the other side. And the only reason I've done that is it's just going to help me graph. So now I know I have a very skinny parabola here. So let's go ahead to the next page and we will try doing this again. All right, this looks a little bit different. It's just that our k value happens to be sitting right here. So first of all, switch f of x into y. So here's what I've got. Y equals 2 minus 1/2 x minus 1 quantity squared. Subtract 2 from both sides. So I'll have y minus 2 equals negative 1/2 x minus 1 quantity squared. Now I've got it in vertex form, and that was my goal because I can graph from this. So first of all, a is negative 1/2. Since a is less than 0, this is concave down. My vertex, remember, is HK, which in this case is 1, 2. So I can go ahead and graph that, 1, 2. And my axis of symmetry is x equals h, which in this case, x equals 1. And I'm going to go ahead and draw my axis of symmetry. And I'm going to label it x equals 1. All right, now I need to find my x and y intercepts. And notice, since this is concave down, I will have x intercepts. So first of all, I'm going to find my y-intercept, and that is the point 0, y. All right, so put 0 in for x, and I have y minus 2 equals negative 1/2, 0 minus 1, quantity squared. So first of all, 0 minus 1 is negative 1. Square that, and I get positive 1. Times negative 1/2 is just negative 1/2. All right? Now I'm going to add 2 to both sides. And I get y equals 2 minus 1/2 is 1.5 or 3/2. So I'm going to go back up here in my y-intercept and fill in 3/2, which is 1.5. And let's draw that point. And I know I have a mirror image point on the other side of the axis. All right, let's now find the x-intercepts. So the x-intercepts are the point x, 0, and x, 0. There will be 2 of them in this case. And we're going to set y equal to 0. So I've got 0 minus 2 equals negative 1/2 x minus 1 quantity squared. The first thing I want to do is get rid of this negative 1/2. The way to do that is multiply both sides by -2. And here's what I've got. 4 equals x minus 1 quantity squared. Now square root both sides. And this gives me plus or minus 2 equals x minus 1. Add 1 to both sides. So I have x equals 1 plus or minus 2. Now 1 plus 2 will give me 3. 1 minus 2 gives me -1. So there's my x-intercepts. And I'm going to go ahead and graph those. So 3, 0, and -1, 0. And now I have enough points plotted here where I can draw my parabola. All right, on the next page, I'm going to start with an equation that is in standard form. And what we're going to have to do is switch this into vertex form. And it's a little bit like completing the square. So this is how I want the equation to end up, vertex form. So let me walk you through step by step how to do this. First of all, I start with my equation in standard form, but I replace the f of x with a y. All right? And I've got my trinomial here. The very first thing you want to do is subtract 1 on both sides. So you want to get rid of this. So I'm going to subtract 1 on both sides. That gives me y minus 1 equals 3x squared minus 6x. The next thing you want to do, whatever number is in front of the x squared, you want to factor it out as if it's the GCF. All right? So when I factor out a 3, I'm left with x squared minus 2x. Now, I want this to be a trinomial that is a perfect square trinomial, just like I did in the completing the square method. So I need a c here. My formula to find c is the same as it was before. b over 2 quantity squared. So my b is -2. So -2 over 2 quantity squared. So what I'm going to add in my parentheses is a 1. Now here's the issue. I've got to add the same thing to the other side. Not a 1, but 3 times 1. All right? I have to remember, I'm not really adding 1 here. I'm actually adding 3 because it's 3 times 1. That's why you see 3 times 1 on the left. All right, so when I take y minus 1 plus 3, that gives me y plus 2 equals 3. And now this factors as a perfect square. So x minus 1 quantity squared. That's the process we need to go through to get this to be in vertex form. All right, now we can see that the vertex is 1, -2, and a is positive, so the parabola is going to open upward. So let's go ahead and graph that vertex. So I've got 1, -2, and since it is opening upward, I will have x-intercepts. I will have 2 of them. So my axis of symmetry is the equation x equals h, which in this case is x equals 1. So let me draw in that particular line. And I'm going to label it x equals 1. So now I need to find my x and y intercepts. So we have a lot of room at the bottom of the page to do this. So find my y-intercept, which is the point 0, y. So put 0 in for x. So I've got y plus 2 equals 3 times 0 minus 1 quantity squared. 0 minus 1 is -1. Square that and I get 1 times 3 equals 3. Subtract 2 from both sides and I get y equals 1. So 0, 1 is my y-intercept. So go back up here to my graph, and I'm going to graph 0, 1. And remember, I have a mirror image point on the other side of the axis. Next, we're going to calculate our x-intercept. So let's go back down to the bottom of the page. And my x-intercepts are going to be the point x, 0, and x, 0. And so what I'm going to do is put 0 in for y. So I have 0 plus 2 equals 3 times x minus 1 quantity squared. The first thing I've got to do is get rid of this 3 that I have here in front of my binomial. So divide both sides by 3. So I've got 2/3 equal x minus 1 quantity squared. Now I'm going to square root both sides. This gives me plus or minus the square root of 2 over the square root of 3 using my product rule equals x minus 1. Now I'm going to have to rationalize this denominator, so I may as well do it now by multiplying by the square root of 3 over the square root of 3. So really what I have is plus or minus the square root of 6 over 3 equals x minus 1. Add 1 to both sides. So I get x equals 1 plus or minus the square root of 6 over 3. And what I'm going to have to do is put this in my calculator, because in order to graph, I will need a decimal. So I've got 1 plus, and then in parentheses, the square root of 6 divided by 3. And that gives me 1.82. So up here at the top, I've got a 1.82 x-intercept. Now I'll do minus. So 1 minus, and then in parentheses, the square root of 6 divided by 3. And that gives me 0.18. So 0.18. Now I need to graph these 2 points. So let's go back up to my graph. And 1.82 is maybe about here. 0.18 about here. And I've got a very skinny parabola. All right, one more example. Let's go through this together. So here we start with an equation that happens to be in standard form, and we want to rewrite it in vertex form. So the first thing that we're going to do, replace f of x with a y. So I have y equals 3x squared minus 12x plus 7. Get rid of that 7. So subtract 7 on both sides. And I've got y minus 7 equals 3x squared minus 12x. All right? Whatever is in front of the x squared, factor it out like it's the greatest common factor. So this is going to give me y minus 7 equals 3. Then I have x squared minus 4x. Leave a space for your c. All right? My c equals b over 2 quantity squared, which is negative 4 over 2 quantity squared, which is negative 2 squared, which is just 4. So I'm going to add 4 right here. But remember, I'm not really adding 4 because it's in parentheses with the 3 in front. 3 times 4 is 12. What I'm really doing is adding a 12. So on the other side, add 12. Now you've done the same thing on both sides. So let's go ahead and simplify. Y minus 7 plus 12 is y plus 5 equals 3. And now we can factor this. This is x minus 2 quantity squared. My next step, I'm going to graph this. I've got it written in vertex form. So first of all, A is greater than 0. So this is concave up. My vertex is HK, which is 2, negative 5. And let's go ahead and graph that right here. My axis of symmetry is x equals h, which in this case is x equals 2. So let's go ahead and graph that axis. And let's label it. Okay, now we need to find our x and y intercepts. So my y-intercept, just one of them, is the point 0, y. So we're going to put 0 in for x. So I've got y minus 7, or I'm sorry, plus 5. I'm looking back at the wrong word. Equals 3 times 0 minus 2 quantity squared. 0 minus 2 is negative 2. Square that and you get positive 4. Times 3 is 12. So I've got y plus 5 equals 12. Subtract 5 from both sides, and I get y equals 7. So 0, 7 is my y-intercept. So let's go back up to the drawing, and this clearly is a very skinny parabola. Here's my mirror image point on the other side. Very skinny parabola. Let's do the x-intercepts. So the x-intercepts are the point x0 and x0. So we're going to put 0 in for y. So I have 0 plus 5 equals 3 times x minus 2 quantity squared. First thing I'm going to do, I got to get rid of the 3. Divide both sides by 3. So I've got 5/3 equals x minus 2 quantity squared. Now I'll take the square root of both sides. This is going to give me plus or minus the square root of 5 over the square root of 3 equals x minus 2. All right, next step, I need to rationalize this denominator. So I'm going to multiply by the square root of 3 over the square root of 3. And this is going to give me plus or minus the square root of 15 over 3 equals x minus 2. Now add 2 to both sides. So x equals 2 plus or minus the square root of 15 over 3. So now I just need to put this into my calculator. 2 plus, remember the parentheses, square root of 15 divided by 3, parentheses, 3.29. So let's go back up here, and we've got 3.29 as one of our x-intercepts. Let's go ahead and do the other one. 2 minus, parentheses, the square root of 15 divided by 3. And I have 0.71. Okay, so let's go back up to our drawing and draw these in. So 3.29 maybe about here, 0.71, maybe about here, and I can go ahead and draw my parabola.